Hello, good evening to all of you. Welcome to Tutrain. I am your mentor Jagannath, and today we are going to discuss the chapter 1 and chapter 2 of class 10 mathematics. So we are not here just to pass the exam, we are here to dominate the mark sheet. So I am seeing the chats flying in the chat box. So before we dive into the syllabus, I want everyone to type their dream math score in the chat box right now. Let's see how many of you want to score 95 plus marks. Alright, so I can see the chats. That's amazing. That is our target, 95 plus marks in our boards 2026. Right? Yes. Alright. So let us get started. So today will be the first lecture of mathematics at Tutrain, and today we are going to discuss the two important chapters. Those are real numbers and polynomials, and we are going to take the most important questions and the previous year questions of these two chapters. I believe everyone is excited. Let's see in the chat box. Okay, hi Vansh, hi Bhupendra, good evening to all of you. So before we get started, you should have studied about all these numbers. Let's recapitulate. So what are natural numbers? The numbers that are starting from 1, 2, 3, 4 and so on up to infinity are called natural numbers, right? And those numbers which are starting from 0, 1, 2, 3, 4 and so on, those are called whole numbers. Now, what are integers? So the integers means the numbers which consist of the negative numbers 0 and positive numbers are called integers. Now there comes a question, what are rational numbers? So we have studied rational numbers are those type of numbers we denoted by Q, which are represented in the form of P and Q, where P and Q are integers, right? That means set of integers and Q is not equals to 0, right? Yes. So such type of numbers, like we have 3 by 4, right? Then we have 2 by 6. These type of numbers are rational number, right? Suppose we have 5, so 5 can be written as 5 by 1, so 5 is also a rational number, and even 0 is also a rational number. Why? Because 0 can be written as 0 by 1, right? Okay. Next we have the irrational numbers. Those numbers which are non-terminating decimal and non-repeating decimals are called irrational numbers. Suppose you see here, suppose I have a decimal number 1.4233958 and so on. So first of all, it is non-terminating. Non-terminating means it will never end. It will go on and on, right? And non-repeating means after the decimal point, the digits do not repeat themselves. So such type of numbers are called irrational numbers, right? And we know that square root 2, square root 3, square root 5, and these are also the irrational numbers, right? Yes. So moving ahead, yes, this is our first question. So I want all of you to try this. Let us think together how to solve this. So here we are given 1 plus square root 3 whole square minus 1 minus square root 3 whole square is. And here we are given the four options. First is a positive rational number, a negative integer, a positive irrational number, and a negative irrational number. Which of the following you think is correct? So I am giving you 30 seconds. You can type your answer in the chat box. Hi Roshan Kumar, Mixed Verse. Good evening to all of you. And meanwhile, you can give your attendance by clicking on the like button. Alright, so let us move ahead. What should be our approach? Now here we can see that it is 1 plus square root 3 square. So we all know a plus b whole square, right? Hi Veer. So it is equals to a square plus b square plus 2ab, right? And we know that a minus b whole square is equals to a square plus b square minus 2ab, right? So if you know these two identities, you will easily solve this question. Now, see, since we know that a plus b whole square is equals to a square plus b square plus 2ab, right? So here we have to find 1 plus square root 3 whole square, right? Now here in place of a, what do we have in place of a? In place of a we have 1, and in place of b we have square root 3, right? So if we expand it, what should we write? We should write 1 square plus square root 3 whole square plus 2 into 1 into square root 3, right? Yes, so it will be 1 square is 1 and square root 3 whole square, so the root and the power gets cancelled out, so it will be 3 plus 2 root 3. So now 1 plus 3, that will be 4 plus 2 root 3. So from here we got 1 plus square root 3 whole square is 4 plus 2 root 3, right? Yes. Now you should find 1 minus root 3 square. So we know a minus b whole square is equals to a square plus b square minus 2ab, right? So here 1 minus square root 3 whole square. So in place of a it is 1 and in place of b it's square root 3. So it will be 1 square plus square root 3 whole square minus 2 into 1 into root 3. So it will be 1 plus 3 minus 2 root 3, which is equals to 4 minus 2 root 3. Now you have two values, right? First, if you can see, we have got this value which is 1 plus square root 3 whole square, which is 4 plus 2 root 3. So let us write here 1 plus square root 3 whole square is equals to 4 plus 2 root 3, and from this you have got that 1 minus square root 3 whole square is 4 minus 2 root 3. Now read the question. So you can see that here we need to subtract, right? So if we need to subtract, let us subtract this, and if I use the subtraction sign, so the signs will changes, 4 and 4 will get cancelled out, and 1 plus root 3 whole square minus 1 minus square root 3 whole square is 2 root 3 plus 2 root 3, which is equals to 4 root 3, right? Now root 3 is an irrational number, yes or no? That means from here we can see that 4 times an irrational number will be irrational number, and since it is positive, so it's positive irrational number. It's positive irrational number. So which option is correct? So the option number C, will be correct, that it's a positive irrational number, right? Yes. How many of you got it correct? Let's see in the chat box. Okay, so let us move ahead to our next question. So now the most important question which can be asked is the concept of HCF and LCM, right? Yes, and we know that every composite number can be expressed as a product of primes, and this prime factorization is unique apart from the order in which the prime factors occur, right? So it is called the fundamental theorem of arithmetic. It's called the fundamental theorem of arithmetic, right? Yes, and its application is found in finding the LCM and the HCF, right? So we know that if we find the HCF and LCM of two numbers, and the product of HCF and the LCM is the product of those two numbers. For example, let's take the numbers A is 4 and B is 6, right? So the prime factorization of 4 will be 2 into 2. The prime factorization of 6 will be 2 into 3, right? Now if I want to find the HCF of AB, means the HCF of 4 and 6, that will be equals to what? So the HCF means the common factor, so the common factor is 2, so my HCF is 2, right? Now what I want to find is the LCM. How to find the LCM? So we write 2 here and we multiply with the remaining numbers. So the LCM of AB will be 2 into 2 into 3, which is 12. Now you see, now the HCF is what? The HCF is 2 times the LCM is 12. So 2 times 12, the LHS will be 24, right? But if you see the product of two numbers, which is 4 into 6, is also 24, right? So it's a standard result that the product of HCF and LCM is equals to the product of those numbers, right? Yes. So let's see one question which has come in this CBSE 2025. So here we are given if x is equals to AB cube and y is equals to A cube B, where A and B are prime numbers, then we need to find the HCF of xy, then you need to find the LCM and then subtract them and then see which option matches your answer. So I want everyone to type the options in the chat box with your correct answers. So here we are given x is equals to AB cube, right? And y is equals to A cube B. Now if we expand this, so x is equals to AB cube means A into B, B is multiplied to itself 3 times, right? Now on the other hand, if you say A cube B, so it is A times A times A times B. Now to find the HCF, what you need to do, you just need to do the grouping. So the common factor will be A and B. So A times B, that means here we got the HCF of XY, which is AB, right? And how to get the LCM? How to get the LCM is that you see the highest power of A, that's 3. So you take this A cube and then see the highest power of B, so that's B cube. So the LCM will be A cube times B cube. Now once you get the HCF and LCM, you just need to subtract them, right? Yes. So now we are going to subtract them. Let's write here. So HCF of XY minus the LCM of XY. So it is AB minus AQ BQ. Now here you can all see that if I take AB common, what are we left inside? So it is 1 minus A square B square, right? So it is equals to AB. Then we can write this A square B square as AB whole square. So it is AB times, now see, this is of the form x square minus y square, which is x plus y into x minus y, right? So here it will be 1 plus AB into 1 minus AB. So my option D will be the correct answer, right? Alright, let us move ahead. Now, which of the following statements is true for a polynomial px of degree 3? This is also the CBSE 2025 question. So the options are: px has at most 2 distinct zeros, px has at least 2 distinct zeros, px has exactly 3 distinct zeros, or px has at most 3 distinct zeros, right? Let us type it in the chat box. Let's see who can get the correct answer. All right. Oh, so now here you can all see that we know that if a polynomial px has a degree of n, then it can have at most n roots, right? Means n zeros. So here, now this polynomial px has degree 3, that means px will have at most 3 distinct roots. So option D will be the correct answer. Next question. Now here we are given that x and y are 2 distinct prime numbers and p is equals to x square y cube and q is equals to x y to the power 4 and r is equals to x to the power 5 y square. You need to find their HCF and LCM. You need to find the HCF of P, Q and R, and also you need to find the LCM of P, Q and R. So to find the HCF, you see, for x you take that variable of x which has the least power. For the HCF we take the lowest possible power. So it is x to the power 1. So we will write x to the power 1 here. Now same for the y. Y square is the least possible. So the HCF will be x y square, right? Yes. And for the LCM we see the highest power, right? So for x it will be x to the power 5 and for y it will be y to the power 4. So easily we can see that the HCF of PQR is x y square and the LCM is x to the power y, x to the power 5 y to the power 4, right? Yes, now they are saying that further you need to check if the HCF of PQR times the LCM of PQR is equals to PQR or not. Okay, so for that let's do the work here. So HCF of PQR times the LCM of PQR. So here we just need to multiply them, right? Yes. So it is xy square multiplied by x to the power 5 y to the power 4. So if we multiply this, so it will be x to the power 1 plus 5 by the law of exponents y to the power 2 plus 4. Let's go to the next page. So if we can see the HCF times LCM, that will be equals to x to the power 1 plus 5, that will be x to the power 6, and this will be y to the power 6, right? Yes, that means the HCF times the LCM is equals to x to the power 6 y to the power 6. Now we will check that if it is equals to P times Q times R. So for that we know that P is x square y cube, right? So and Q is xy to the power 4 and R is x to the power 5 y square. So here we need to find P times Q times R, which will be equal to x square y cube times x y to the power 4 times x to the power 5 y square. Now by the laws of exponents, if you all can observe here, for x this will be 2 plus 1 plus 5 times for y, we can see by the laws of exponents it will be 3 plus 4 plus 2. So that will be equals to x raised to the power 8 y to the power 9. That means we have seen P into Q into R is equals to x to the power 8 y to the power 9, but the HCF times LCM is x to the power 6 y to the power 6. That means clearly we can see that HCF times the LCM is not equals to P into Q into R. I believe this is clear to all of you. Alright. Hi Ishan, very good evening. Now next, the quadratic polynomial, the sum of whose zeros is minus 5 and their product is 6 is, right? So you have to find this. Now here they are given, we have read in polynomials that if we have ax square plus bx plus c equals to 0, right? So this is a quadratic polynomial, we all know this. So for this we know sum of zeros, that is equals to minus b by a, and product of zeros, that is c by a, right? So if we compare this with, yes, so now we are given that the sum is minus 5 and we have we know one formula how to get, so it is x square minus sx plus p is equals to 0, where what is s? S is the sum of zeros and p is the product of zeros. So here s is given to us as -5 and p is given to us as 6. Let us put it. So x square minus and s is minus 5x plus p is 6 is equals to 0. So it will be x square, negative times negative is positive. So x square plus 5x plus 6 is equals to 0. So my option will be option number A. This is also the CBSE 2020 question, right? Let us move ahead. Okay. Now if one of the zeros of the quadratic polynomial x square, so it is x square plus 3x plus k is 2, then you need to find the value of k, right? Alright, so I can see the answers in the chat box. Let's see. One have typed A, Rachit has typed A. Okay, so the best approach is that let fx is equals to the polynomial x square plus 3x plus k, right? Now they are saying that one of the zeros is 2, right? One of the zeros is 2. That means if I put 2 in this, what will be the f2? So the f2 will be equal to 0, right? So let us put f2 is 0. So from here, if you can see f2, that will be in place of x, just put 2. So it will be 2 square plus 3 times 2 plus k, and this is equal to 0. That means 2 square will be 4 plus 2 times 3 is 6 plus k is equals to 0. And from here 10 plus k is equals to 0. So 10 plus k is 0, and if we transpose this 10 to the RHS, k will be minus 10. So the correct option is option number B. Very good. Alright. So next question is this. If p and q are positive integers such that p is equals to ab square and q is equals to a square b, where a and b are prime numbers, means you can see the prime factorization of p and q, then what you need to find is, you need to find the LCM of p and q. And here you have the options. First option is ab, second option is a square b square, third is a cube b square, and fourth is a cube b cube. Let's see who can get the correct answers. So I want all of you to type it in the chat box. Let us see. So here I have told you the trick. How to find the LCM is, for a you take the highest power of a. Highest power of a is 2, so we take a square. And for b you also take the highest power of b, so it is b square. That means the LCM is a square b square. So the option B will be correct. I can see that many of you have typed B. That is amazing. Okay. Now if I give you a challenging question, that can you all type what will be the HCF of P and Q? Let's see. Alright, so how to find the HCF is that for HCF we take the lowest power, right? So for A we can take A to the power 1, and for B also we can take B to the power 1, so it will be AB. Very good. Greek edits has typed the correct answer. Amazing. Great. Make sure to like, share and subscribe to this channel. Let us move to the next one. If the sum of zeros of the polynomial, so the polynomial is this 2x square minus k root 2 x plus 1 is root 2. Sum of the zeros means here you are given sum of zeros is equals to square root 2. Then you need to find what? You need to find the value of k. And you have the options square root 2, 2, 2 root 2 and half. Let's see who can get the correct answers in the chat box. Okay, so I can see some of you are typing. Now, we know that if we have the quadratic polynomial ax square plus bx plus c, right? So, sum of zeros is equals to minus b by a, right? Now here we are given the sum of zeros as square root 2. Square root 2, and if you compare this with ax square plus bx plus c equals to 0. So from here you will get a is 2, b is minus k root 2 and c is 1. So minus b by a will be minus of minus k root 2 by 2, right? Yes. Now we will just simplify this. Yes. So from here we got root 2 is equals to minus of minus k root 2 by 2, right? Yes. Now negative into negative, that will be positive. So we can remove the brackets and then cross multiply. So if you cross multiply this will be 2 root 2 is equals to k root 2, right? Now to get the value of k, what should we do? We should divide both sides by square root 2, right? So now you can see the value of k is equals to 2. So the correct answer is option B, which is 2, right? Alright, very good. Next, if two positive integers p and q can be expressed as, p can be expressed as 18 a square b to the power 4 and q can be expressed as 20 a cube b square, where a and b are prime numbers, then you are asked to find the LCM of p and q. Okay, and here you have the options. The first option is 2 a square b square, second is 180 a square b square, c is 12 a square b square and d is 180 a cube b to the power 4, right? Now I have told you the trick to find the LCM, so we will always check for the highest power. So for a cube will be the highest power, and for b to the power 4 will be the highest power. So we will discard the option number a and option number b also, right? Because it will be a cube b to the power 4. But you need to also find the LCM of 18 and 20, right? You need to find the LCM of 18 and 20. So you can just use this method which we have learned. we can use this, and the LCM will be 2 times 2 times 5 times 9, that will be equals to 180, right? So it will be 180 a cube b 4. So the correct answer is option number D. Alright, many of you have typed D. Okay, great. Next, the total number of factors of a prime number is, the options are 1, 0, 2 or 3. Let's see. So for that, we know what are prime numbers, right? So prime numbers are those numbers which have only two factors. They have only two factors. What are those two factors? 1 and itself, right? So the total number of factors of a prime number is 2, right? So option C will be correct answer. Okay. Now we need to find the HCF and the LCM of 12, 21 and 15. And here for the HCF you have the options 3, and for the LCM it's 140, 12, 420, 3, 420, 420 and 3. So I will give you 20 seconds to solve this, and let's see who can type it first in the chat box. Let us see. I can see many options B, D. Okay, let us see. You can use prime factorization method or any method which you want to use. Alright. Oh. So here, let's first do the prime factorization, right? Let's first do the prime factorization of 12. So 12 divided by 2, it will be 6. 6 divided by 2, it will be 3. So its prime factors will be 2, 2 and 3. So it is 2 times 2 times 3, right? Yes. Now for the next 21, for 21 also we will do the prime factorization. So 3 times 7. So 21 is 3 times 7. And for 15 we can do it. So 15 by 3 is 5. So 3 times 5 is 15, right? This is the factor tree method. Now among the following, we can see that if we are finding the highest common factor, so only 3 is common in all 3 of them. That means the HCF will be 3. So we will discard the option B and D. Correct? Yes. Now we will have the answer is either A or C, because the HCF is 3 here, right? Yes. So now next we need to find the LCM. How to find the LCM? Now since we are done finding the HCF, so the LCM will be equals to, first this 2 times 2, 2 times 2 times 3 is 1 times 7 into 5. And if you multiply this, you will get it as 420. That means the LCM is 420 and the HCF is 3. So the option number C will be the correct answer, right? Yes. Okay, so this is the final question for today. 36 can be expressed as a product of its prime. So basically what you need to do is you need to do prime factorization. You need to do prime factorization of 36. You have the options. You can type it in the chat box. Let's see who can get the answer first. So for the 36, we can also draw the factor tree diagram. So 36 divided by 2, that will be 18. Then 18 divided by 2, that's 9. Then again 9 divided by 3, that's 3. So the prime factorization of 36 will be 2 times 2 times 3 times 3. Now 2 times 2 can be written as 2 square, and 3 times 3 can be written as 3 square. So it will be 2 square times 3 square. So the option A will be the correct answer, right? Alright. So every child has the power to shine. So you can start now by enrolling with us, and thanks for joining, and like, share and subscribe to this channel, and we hope to see you in all the live PYQ sessions. Thank you so much. Have a great day ahead.